Alright, welcome to Doozer shop. We've got another block of steel set up in the Clausing 8520 mill, and what we're going to be doing, last time, this is the finished one, we milled this slot for the attaching bar and tapped these holes for the cap cover, the cover plate, I guess you'd call it. So now we're going to mill the slot where the tang, the tab, the finger bolt on the rocker goes. So we've got it set up in the mill right here in the vise, and it's going to be 5/8 of an inch deep, and I forget, I'll double check the width, it's 0.572 or 579, but I got it set up in the mill and I got it touched off with the edge finder. I didn't record that because you guys know how that works. I'm going to touch off to get my depth, my zero, using a 3/8 end mill, so I should have plenty of stock. I'm going to go down to approximately 620, leave a little cleanup, slot it through 3/8, and then move over until I get my 0.54 whatever number. So here we go at Doozer shop. Feed the knee up until I touch off, and then I'm going to zero the knee dial. Alright, that's zero. I might crank in a... Alright, there's zero. Maybe cranked in a half a thou. Alright, let's go, I gotta go 625 deep. So let me get a slot going. Let me do 50 and then another 50, and then I'll start doing 100,000 increments. I believe that's going to be a workable thing. It's what I like to do anyways. Again, 1,000 RPM. 50 thousandths. I got the Y locked. Here we go. Oh, got the quill locked as well. It's 50, and this will be 100. Alright, we're going to crank 200. Well, crank 100 for a total of 200. It's 200, let me go another for 300. Turn it up a little. That was 3, here's 4. will be 5. This will be 6. I should be at approximately 600 thousandths deep. Now, I changed my end mill. This is a nice, sharp end mill. My old end mill, the corners were getting a little chipped up. And like I say, it was a used end mill, so they started a little chipped up to begin with. You see how I flipped that file over? Most files are not perfectly straight. They got some banana to them. So there's always a convex and a concave side to a file. And I like to, you can tell which side of the curve of the file you're using when you flip it over, use one and then the other. You say, okay, because the concave will deburr the inside like that in the center of the part, and the convex will, the concave will tend to deburr the inside or the face, and the convex will hit the back edges ever so slightly now, you know. I'm at like 605. 604 and a half, 605. So I got 20 thousandths more to go. Let me do 15. 10. 15. All right. I'm assuming that's going to be good, but let's check it. $6.16. All right, but 9 more. This is cutting pretty well. I don't suspect it chatter out the bottom. That's okay. We'll clean it up. So let me get a dimension on this. So this, the one I made, 547, 548, 547. Let's shoot for that. 547. Alright, so I zeroed my calipers. Alright, I got to take off 160. Okay. So that's 80 thousandths per side. 8 and 8 is 16, so 80 is 160. So I'm going to take like, let me work my way up to 60 thousandths or so. Let me go to 50 and then I'll measure it again. It's 25. Conventional cut. Okay, go to the other side, do 25 again. And I'm going to come out to 50 now on this side. 25, 34, right, here's 50. Okay. 50 this side. Alright. Let's measure it. Alright, 75 thousandths. Half of 75 is 37 and a half. So let's go 30 and 30. So 50, so 60, 70, 80. So let's take it up to 80 and run our numbers there. Alright, there's 80. I love it. Alright, let me go 80 on this side. We're just doing conventional cutting, we're not climbing yet. Okay. We're still on the minus. Minus 14. So I'm either gonna take 7. So let me take 5. So let me climb cut 5. So let's go to 85. No, this is climb cutting. I'm going back the other way. Alright, 85. You can go back this way to 85. We're going to climb cut back this way. Alright. Alright. Looks like 5? 5. 4.5. 4. Well, let's call it, we need to take 4, and then I'll start fitting the hex head, the bolt, the head of the Allen bolt. So if I need to go 4, I'm at 85, so I gotta go half of 4, which is 2. So 86, 87. So let me go run the numbers at 87 and climb cut 87. 88. 87, lock. Alright, go 87 on this side. 86, no, past it, go back. 88, 87, lock the Y, 87. Alright. So we should be within a thou or two of our number here, zeroed out on the caliper. I am zeros minus, I am zeros all the way across. Let me go get my mating piece. Let me go grab the mating piece, and I will, which is the bolt and the spacer. And actually, first, let me go down deeper. I need to go down. Oh, what was it? Another. Like, the hell was it? Like another 9 thousandths? Oh, 618. Another 5, I think. 620. So let me go another 5 on the depth. So I'm going to crank the knee up. Alright. So let me back this up. 8, 8, 5. Alright. I was at 87 and I backed it down to 83. So when I walked through there, I didn't touch the walls. And let's just, I was at 620, I took 5, I should be at 625, oops. $626, perfect. 626. 625 on the nose if everything's square and you hold your mouth just right. Alright, I'm happy with that. I'm going to get my piece and I'll be back. Alright. We got our piece here. Alright, you guys can, that's that Allen head bolt and a spacer. So we're going to put it, see how that fits? Man, it's a line to line fit, okay? See how it sticks in there? It's a little too tight. Little too tight there, folks. Now, the fit I want to achieve There you go. So that's what I want to achieve. So it's a little too tight. So I was running, my offset was 0.87. Let me crank it up to 0.87 again and run the number, just the same number, take any spring out of it. It's called spring pass, right? 87, 0. Alright, it took a little. Let me go 87 again. Oop. 88. 87. Alright, let's check that out. Better. It's still tight. Alright, maybe. Let me run it back through conventional cut. See if it does anything. Might not. No. You can go 87.5 on this side. 87. All right, so it's 0.0875, so 87.5 thousandths. Before I do my other side, I'm going to check the fit here behind the end mill. You might not be able to see it. Oh no. I like that. There. Fits really good. I'm glad I did not run the other side. Here's this one. I think that's exactly perfect. All right. I'm super happy with the fit in that one and in the one I just cut. All right, another part down. Let's see what's next. All right, guys, wanted to show you my setup here. So I got my piece in the vise with some V-blocks on both sides. So now it's sitting at 45 degrees. So what I'm going to do is I'm going to put a chamfer lead in on this corner, that corner, and this corner, and this corner. And what that's for is so this thing, you know, I'll show you this way. It's going to come and slide into position, right? It's going to kind of arc into the center, and it's going to live in the center when the rocker box is engaged, and it's going to disengage, and it's going to be kind of up there like that, okay? Not the exact arc I'm showing you, it's a larger radius arc, but you know, you get it. So what I want to do is break these edges, and it's only going to come in one side, but I figure I'll make it symmetrical. And that's why this is I'm using an Allen head cap screw. Is the head of the bolt, of course, is round, and I want to put some radius on here to guide it even more, because as you know, this thing's going to slide sideways, drop in, pop out, slide sideways, go to the other one, drop in, drop out, slide sideways, drop in. So that's why I'm going to put a chamfer on both sides. Like I said, it only needs to be technically one side, but I'm going to reposition the camera because I know it vibrates if I try to mill. Well, maybe not. Let's see. I'll just pull you back some. Maybe it won't vibrate too bad. Let's see. What the hey. Unlock. Yeah. Sure, that's unlocked. Alright, I gotta set my depth too. That's gonna be a little tricky maybe. Really don't want to take any off. Alright, that is just barely taking the magic marker off. And so I'm going to zero my knee, and I'm going to actually drop down 2 thousandths or so, 3 thousandths. Hell, let me go 5. The heck's the difference? Okay, I'm within 5 thousandths of the floor. And I don't know how much I'm going to take off. I'm going to kind of eyeball it. So let's see what we can come up with here. First of all, I guess let me get close. I think I cut something there. Zero my readout. Maybe. I think I just touched it. Let's see what I can do. Yup. That was 2 thou. Let me crank in 10. Let me go 30. $30 looks good. Let me go more. Let me go 45. We're climbing here, just gotta be careful. I'm gonna go 60. Yeah, I like 60. Yeah, it looks about right. Yeah. Alright, I like that. I could get closer. I was back 5 thou. Alright, there's another 2 thou. Alright, I dig that. Now, I'm going to cut this one right here. Right here, as they say. Here. I don't know who they are. I guess that's what I say. Alright, let me get close here. Yeah. I believe that was like a thou. Alright. We crank in 10 or so. Yeah, that's looking good. Let me go for 30 and then 60. Let me climb this, because why not? Let's go 45. And then 60. It's conventional. Let me come back out of it, climb. Very nice. Yeah. Stellar. $60. Let me stick my big fat head around. Let's see here. Alright, now for the last one. And that's what we got there, folks. Nice. Alright. So that'll allow a nice, smooth entry. Of our piece. Oh yeah. Oh yeah, that's sexy for sure. Alright. I'm not going to film the other one. You kind of get the idea. But that's how very useful these V-blocks can be when you're setting stuff up in the mill. These are actually Enco V-blocks. I love Enco stuff. Back in the day. Nostalgia. Tool buying nostalgia, Enco. Alright folks, that's it for that. I'm going to set up the other one and run it, and we'll show you more. Alright guys, got you back. Got that last part done. These are the cutoffs of the pieces that we started with. Actually, they started off like this, and this is bandsaw cut on this side, and you can see the end where it tapers out. So these are the cutoffs from the bar. These are actually sheared at the bar mill, where they manufacture the steel and roll out the ingots into the bars. So these are the end cuts. Well, those are the end cuts. This is an end cut from a long, 20-foot bar, and this is the scrap, the waste. And I was actually able to utilize, that much of it for making my pieces that I showed you guys in the last part of the video. But what's left is, just the raw, rough cutoff from the parting shear. So I got them on the parallels. They're bandsaw cut, edge down against the parallels. So I'm going to mill these up and make the end caps for the pieces I just made with the 4 screws in there. I got the corncob carbide 1/2-inch diameter roughing end mill I'm going to be blasting through these with. Let me set the camera back a little ways so you don't get the vibration, and we'll start cutting. Alright guys, I got all the chips vacuumed off, left a decent finish. I'm going to do is drop these upside down on the surface grinder, grind the underside, which is the bandsaw cut side, then I'm going to flip them over and hit this one more time. Just because I like using the surface grinder, and smooth finishes are nicer. And I'll show you guys some grinder footage. So I'm going to take these out and come back, and you'll be at the grinder. Alright guys, we're back at the Boyer Schultz surface grinder. I got the 2 pieces magged down to the chuck. The milled side I just did is pointed down. The bandsaw side's pointed up. I'm just going to touch this off, do some cleanup, and just make them flat, both sides parallel. I don't care if the sides, the edges, are not 90 degrees. They're very close. But fan makes a little noise on the VFD, but we're going to touch off and do some grinding. Here we go. Oh, you know what? And excuse my head if it gets in the shot during the touch off. You see they're a little different heights, not much. You can see it there really clearly. They were within 2/1000ths, less than 2/1000ths of each other. Now we'll do a little bit nicer grind. Take off 2 thou. 2 thou on the down. right, let me take half a thou for the final. I'm not trying to hit a size here at all. All right, here's half a thou. All right, I'm pretty happy with that. Good finish. There's like no heat in the part, which is excellent. All right. And I dressed the wheel last time. I didn't dress it this time because I know I still got a good edge on my wheel. I'm gonna take these off the chuck. Well, I'll show you. I mean, it's an okay finish. You know, I'm not going for anything other than just, okay, now I'm gonna hit this milling that I did on the mill. I'm gonna flip them over. I'm gonna clean the chuck off, flip these over, and bring it back.